system of equations is just two or more equations that share variables. So I'm sharing x and y in this case. This one's a tricky one because one of my equations is quadratic. We can tell it's quadratic because it has an x squared there. And the other one is a line. So you could solve this graphically, right? I think we're going to get a parabola for one and a line for the other. So what we're looking for if we are thinking about solving a system graphically is we're looking for the places where they intersect. In other words, the x, y points that lie both on the parabola made by this and that lie on the line. That's what solving is in this case. It's finding an xy pair that works when you plug it into both functions. In other words, when you plug in the x, y point into both of these, they both are true. So we're going to try to solve this algebraically, and we're going to do it two different ways. Alrighty? Here we go. But you could solve the system graphically if you wanted, right? You would just get y by itself, and then put it y1 equals, y2 equals, and see where they intersect. All right. You know what I'm going to do first? I'm going to try to solve this system using the tried and true method called elimination. And we call it elimination because we try to eliminate one of the variables. I've got two variables. I have an x and a y, and I want to get rid of one of them. Okay? This is kind of like a tricky little maneuver, and we've done it before when we've solved linear equations, but I think it's going to work nicely. Usually when we eliminate a variable, we try to add up to down. So take a moment and just imagine if you added things up to down, would you be able to eliminate one of the variables, either the x or the y? You're right. You could eliminate these y's. I could eliminate those y's. Wow, I just moved something. That was weird. Okay? If I add it up to down, can I just add up to down? I don't know. Let's just try it. Let's see what happens. I'm just adding things. Okay, x squared plus 2x. Well, those aren't like terms. X squared plus 2x is just x squared plus 2x. That's a little weird, but let's just go with this. So I've taken care of those. Negative y plus y. Ooh, poof, they go away. I'm liking that. Equals x plus 5. Well, that's just x plus 5. 7 plus, I guess, 0. All right, so I'm doing this kind of a funny way, but does that kind of make sense? I just kind of added things. And everybody was involved. X squared is there, that 2x is there, those went away. X plus 7 plus 5, it's all there. All right, now I have an equation with one variable. We know how to solve this. This is a quadratic. And I can solve a quadratic by getting everything over onto one side, setting it equal to 0, and then either factoring or using the quadratic formula. So let's do that. Let's bring this x over. So I'm going to subtract x from both sides. Okay. So I have x squared. 2x minus x is an x. Let's see. So I got rid of that. Oh, that's a 12. 7 plus 5. So I'm going to subtract 12 from this side. And there we go. I have x squared plus x minus 12 equals 0. If you need to pause the video and kind of put that on paper and do it yourself, and I think you'll end up getting what I just got. Now, if you like factoring, you can factor. If you're freaked out about factoring, you can do the quadratic formula. I'm going to factor because it's good to practice. Remember, factoring is just undoing double distribution. So I'm looking for a number here that when I multiply, I get x squared. So I'm pretty sure that's going to be an x times x. The numbers that go here and here have to multiply to equal 12. Well, let's see. What options do I have? I have 6 and 2. I have 1 and 12. I have 3 and 4. Let's just try, I don't know, let's try 6 and 2. Let's see if that works. Now it's a negative 12, so one of those has to be negative, one has to be positive. And now I'm going to just do a quick check. I'm going to multiply them together to see if they work. Let's see, x times x, that gives me my x squared. X times 6, that gives me a 6x. Negative 2 times x, that gives me a negative 2x. Negative 2 times 6, that gives me a negative 12. Okay, the first term is good, the second term is good. 6x minus 2x, wait, that's not going to work. That's going to give me a 4x, and I want a 1x. Are the 6 and the 2 even going to work? I don't think they are. So I'm going to go back to the drawing board here and think what other factors will multiply to equal 12. Are you thinking about it? Maybe 3 and 4? Because I think the 3x and the 4x will work. Let's try a 3 here and a 4 here and see if it works. Again, let's do our little check. X times x, x squared. X times 4, that's a 4x. Negative 3 times x, negative 3x. Negative 3 times 4, negative 12. Oh, that's going to give me 4x minus 3x. That's going to give me a positive 1x. Yay! I'm successful. So now that I just checked that, I can now keep going since those multiply to equal 0. That means either x minus 3 equals 0 or x plus 4 equals 0, which means x equals 3, or x equals negative 4. Yay! We think we're done, but wait, we're not done because remember what we talked about originally. I'm looking for xy pairs that solve the system. So each one of these x's, when x equals 3, I have to find its little partner friend, okay? When x equals negative 4, I have to find its partner, its y friend. So I'm going to go back to one of my two equations. It doesn't matter which equation we use. I'm going to pick the easy one right here. 2x plus y equals 5. 2x plus y equals 5. Well, I am going to temporarily, let's do a little color coding here. I'm going to sub in that 3 and find the y that goes with that x equals 3. So let's see, I'm just going to solve this equation. Okay, to get y by itself, I'm going to subtract 6. So I'm pretty sure that when x equals 3, my y equals 1. So I found one of my solutions to my system. When x is 3, y is negative 1. Hooray! But wait, there's more. I have to find this second solution when x equals negative 4. Well, let's use that same nice equation. You could use the harder one, but let's not. So now I'm going to sub in a negative 4 for that x, and see what y goes without x. So I have negative 8 plus y equals 5. To get y by itself, I'm going to add 8 to both sides, so I get y equals 13, and that's the y that goes with that x. And here are my two solutions. 3, negative 1, and negative 4, 13. If I graphed those, if I graphed that parabola, and I graph that line, they would intersect at those 2 points. For those of you who didn't like the elimination method, let's just at least start this problem using a substitution method. Substitution means you usually solve for one variable and then substitute it in the other equation. So let's look and see how we could do this. We could do this a couple of different ways. I know a lot of you folks like getting your y's by themselves. So I know since you like that, let's do that. Let's rewrite each one of these so that y is isolated, okay? Now this first one right here is a little easier than the other, so let's start with that. How can I get y by itself? Oh yeah, I could just subtract 2x from both sides. Let's do that. So that first equation there is, I can rewrite as y equals 5 minus 2x. Everybody cool with that? I just rewrote that first one by subtracting 2x. All right, this one's a little trickier. Oh, but you're saying that's not too hard. I can just subtract x squared from both sides. Okay, I can do that. Let's subtract x squared from both sides. So over here I have x plus 7 minus x squared. Oh no, but I'm left not with a y over there, but with a negative y. That's a little awkward. If we want a y there, how can I get rid of that negative? That's right. I can do algebra. Whatever I do to one side, I do to the other. I can just multiply both sides by a negative 1. So I have y equals negative x minus 7 plus x squared. Okay, so I just did some rewriting and I isolated y for both of my equations. If that's the case, if y equals this and y equals that, then that means that 5 minus 2x must equal negative x minus 7 plus x squared. I just set them equal to each other. And I'm back to an equation that just has x in it. All right. Now this might look weird, but I'm going to do what I did before. I'm going to identify my x squared, right? I want to bring everything over with the x squared and set it equal to 0. I'm going to put the 0 over there because I want my x squared to be positive. So let's say I'm going to subtract 5 from both sides. I'm going to add 2x to both sides. And let's try this. I'm going to write it in order with the biggest exponent first, x squared. Let's see, this is negative 1x plus 2x, so that's going to give me a plus 1x. Negative 7 minus 5. Holy smokes, I'm back where I was before. I have a quadratic now. I can solve that, factoring quadratic formula. We already did that whole thing in the last example. We got x equals 3, if you recall, and x equals negative 4, and we found the partners. We just started the problem differently. This is a tricky system, okay? So practicing these really can be helpful. Also, let me just remind you, you could go ahead and put that in your calculator. Y equals 5 minus 2x. Y equals negative x minus 7 plus x squared. This one's going to look like a parabola. This one's going to look like a line with a negative slope. I guess that's negative for you. And I think you will see that they intersect at 3, negative 1, and negative 4, 13. I hope this was helpful.
I went to stay in, get things done.